Hello and welcome to another video. In this video we're going to be working on count servers that communicate. And this one you're given a map of a server center represented as an n by n grid, where 1 means you have a server and 0 means you don't. And 2 servers communicate if they're on the same row or the same column. Return the number of servers that communicate with each other. So here nothing communicates because these are not on the same row or column. Example 2, these communicate and these communicate, so every server communicates with at least one other server, so all of them do. And then here, these communicate, and this one is not. So we have 4 that communicate. So there's kind of 2 ways of doing this problem. One's really obvious and one is a little bit trickier. So if we just have like a grid, let's have a bigger grid, like this. And we just place servers in random locations. So let's say we have a server here, server here. Okay. So essentially, the brute force method would just be for every server, check the row and the column and see if there's another server. And that solution would be, like if this grid is n, that would be n squared. And that's not going to work because if you look at the constraints, this is, so m by n is 250 by 250, so the whole matrix takes 250 by 250 to traverse. So if you were to do an n squared, you would have another 250 by 250. So you're looking for like a linear solution ideally where you don't have an n squared solution. But instead what we can do is we can just pre-compute the count of all the servers for every row and column ahead of time. And then we can go through this again and we can just check like, okay, for this server, is the count on this row or this column greater than 1? And if there is, then the server can communicate with the with another server. So essentially we can just have like a dictionary or array or whatever we want here. And we can just pre-compute this. So for the rows, we can just say like this is row 0 or 1 or 2 or 3, whatever. So this row has a count of 1, this row has a count of 2, this row has a count of 1, 1 and 2. And then the column is going to be 1, 2, 2, 0, and 2. And so here, basically, like now we can go through the server, and then we can just look, like, does its row or its column have more than 1? So for this one, it has 1 and 1, so it doesn't communicate with anything. For this one, it has 2 and 2, so this one communicates. This one has 2 and 2, so this one communicates. This one has 1 and 2, so communicates. 1 and 2 communicates. 2 and 2 communicates, and 2 and 2 communicates. So essentially here, out of all these 7 servers, 6 of them communicate, so your result will be 6. The other way of doing it, I think this is like the easy way, just maintain a count and just check like what's my count. The other way of doing it that I'm pretty sure will work, we're not going to code it, it's just going to be more of a pain, is using a union find. So basically what would happen here is you would do a union find and then you would connect servers, and then a union find tells you 2 things. It tells you like what's the root of my server, and then what's the rank of my server, and then we can just have another variable in the union find called like number in a group, basically. So number of items in a group. And we can easily do that because whenever you connect groups in a union find, you can just add these up, right? So if one group has like 3 items and another has 4 items, and then a new parent is this guy, then we can just say like the new group will have 7 items. And so this is going to be like a trickier solution. Essentially, I'll kind of just walk through like the big overview of how it would work. So essentially what would happen is you would go through. First, you'd have to map a server to an ID because the union find just takes an array of items, which is pretty easy. Like, all you have to do is just go through the servers and then just give them all a unique ID. So, like, this would be server 0, server 1, server 2, server 3, and so on. You can just maintain, like, a variable ID. That way, you give every server an ID. So, essentially, this will be 0, 1, 2, 3, 4, 5, 6. Then, when your union find, and you can just have, like, a hash map of, like, coordinates to ID or whatever. Then in your union find, what you would do is you would go through every row and then you would connect items on every row, and the same thing for the column. So here there's nothing to connect. Here you would connect these 2. Here there's nothing. Here you would connect these 2. Same thing for the column. So nothing, connect, and then connect. and connect. And so in your result, you will basically have two groups in your union find. This group will have one item, and this group will have a bunch. And then all you need to do is just look for groups that have one item, and that's how many servers are not connected. And then everything else is connected. So it's just going to be like a lot trickier code in the same runtime. So, but if you were to get asked, like, what's another way we could do this, union find would be another way. But so let's code up the array way. That's a lot easier, just the counts. So essentially, all we need is an array of row counts and column counts. So we can do that. So essentially, we're going to make an array of each of these. So row counts. Just going to be an int slice of length. So how many rows do we have? So those are just rows. And call count same. And int slice in Go is basically just like a dynamic array. You could make a static array if you wanted to as well. Either one's fine. Doesn't really matter. Okay. So now we're going to go through the grid. So for equals 0 is less than rows. And then the way this little thing works in Go is you're basically dynamically allocating a type. So because you say r equals 0, this will automatically be an int. Kind of like same thing as in TypeScript. If you don't give a type, it'll just like figure it out. So, or you could give it a type specifically and then use equals. Either one's fine. So same thing here. So essentially we're going to say row counts, or if grid row column equals 1. And yeah, if statements also in Go are very similar to Python. Instead of having the colon, you just have parentheses. Same thing. And so, yeah, so basically, if this is true, then row counts at the current row plus column counts the current column plus. Then we can make a result variable, and we'll just do another traversal, and for every server, we'll just check the count. So if this is 1, and the row count is greater than 1, or the column count is greater than 1, then we can say this server is connected. So row counts row. And we can do this another way. We can write it like this. It's greater than 2. Because if there's only one server, this would be 1, this would be 1. So if it's greater than 2, there's more than 1. So we can just append here. And return. And that should be it, I think. Oh yeah, so same thing. Because we didn't give it a type, you could do this instead. Or you could dynamically allocate it with this if you don't give it a type, either one. Okay. Okay. And yeah, as far as runtime, not super concerning, because this is still going to be optimal. You can do a one pass, I guess, if you like manipulate the grid directly. You can like store some stuff there, but I'm not going to do that. Or, sorry, I don't know if you can do a one pass. I don't think you can do a one pass, but you can have a no one space solution, which I guess will be faster if you just manipulate the grid directly instead. So, yeah. So this is mn, because essentially we're going through this once and then once again. And then space. So we have an array length rows, we have an array length columns, that's just m plus n. And yeah, union find would be mn time, and then space worst case would be mn, because if there's a server in every single cell, union find would have every single server in that thing. So union find would actually be worst space, but just another way to do it. Yeah, so that's gonna be all for this one. Hopefully you liked it. If you did, please like the video and subscribe to the channel, and I'll see you in the next one. Thanks for watching.